So let's take a look at those irrational numbers again. Just to remind you, irrational numbers cannot be written as a ratio of integers, and that's just a fancy way of saying a fraction. So no fractions. So a ratio of integers is a fraction. So that's just a fancy way of saying the same thing there, right about there. And their decimal form does not stop and doesn't have that repeating pattern. So I've got some famous examples there that we looked at, like pi and the square root of 2. Notice all of these have that repeated because they keep going. Pi is super long, infinity long, in fact. So I can't write it all out, but I've put the first ones, couples there. Just making up some more. Remember those decimal forms? They don't stop and they have no pattern. I don't know what's going to come next. And then we also can have the kind of funky one. Like this. So I keep using the same numbers over and over again, but I couldn't write it with that repeating. I couldn't call that 7 and 23/100ths repeating with the bar over the top, or I guess 32. And that's because I've got all these other numbers besides the 32 in there. I want to take some time and look at some of the famous irrational numbers, the square roots. There are literally infinity irrational numbers that are not square roots, but I do want to look at these square roots. We're going to look at them in terms of radicals because we're going to do square roots, and then we're also going to come over and do some cube roots as well. So we can actually do any sort of radicals. We can do fourth roots, fifth roots, sixth roots. We're only going to do squares and cubes. So I'm just going to call them radicals, but we'll start with those square roots. So we have things like the square root. You can have, like I said, the cube root that has a little 3 sitting on top of the box there. And these are the opposite of exponents. So we've been looking at exponents throughout the semester, but if we want, they're the inverse of exponents. So if I want to undo an exponent, then I take a square root. So I'm going to be solving some of these equations as we go along in this section. And when I solve those, I'm going to use the idea of the squares and square roots being inverses of one another. So we're going to estimate these, and I know you could totally type these in your calculator, but just so you get an idea about what's going on with square roots, I want to take you through this process. There are perfect squares that we know. For instance, the square root of 100 is 10. The square root of 25 is 5. So they do have those perfect squares. So I'm going to have that idea. I'm actually going to do the square root of 30 over here since I just did the square root of 25. The square root of 30 is going to be in between two perfect squares that I know. So it's going to be some number between 5 and 6. So it's going to be 5 point something. It's going to be that square root. And you can check in your calculator to figure out what those square roots are. It is good to know some perfect squares. That's just kind of why I go over this. And so you get a sense of what square roots, how they act. 12 squared is 144. So that's pretty close to 150. Since 12 squared is 144, that's one I know. I'm going to see what 13 squared is. And type in that in my calculator. 13 squared is 169. So a square root of 150 is in between 12 and 13. It's 12 point something would give me that square root of 15.